dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
This is Ramadan Kareem. This is Amano e-learning program from trees. Welcome back. This is our video lesson 3. So we were in the revision classes. The chapter or the topic was a periodic table. So if you remember, we were here. So we came across these groups of elements. So this slide is very important. Element is in the same group. We came across groups again, periods. So what is the importance of the group, or what are the importance of the periods? So let us come to the groups. So groups of elements. Elements in the same group have a similar both chemical and physical properties, which means what? They behave in a similar way. For example, at the side of chemical properties, they have, for example, group 1, they have a 1 electron in their outer shells, which means they lose 1 electron in the same way, and they have a similar tendency to lose electrons. What about the physical properties? They have a similar color, similar shape, similar melting point and boiling point, taste, what we call viscosity, density. So they have both similar, both physical and chemical properties. Not only group 1, even if you go to group 7, what we call halogens, they behave in a similar way. So all groups, all elements in the same group should have what? Similar, both chemical and physical properties. What about this one? They have a same number of valence electrons. Valence electrons means outer electrons. For example, if they are group 2, they have 2 electrons in their outer shells. If they are group 3, they should have what? 3 electrons in their outer shell. So valence electron and outer shell electron is the same. So the group number and the outer shell electron is the same. What about the number of electrons in their outer shell? Is the same as group number. For example, 1 to 7. Here we have, they will form a same kinds of ions. For example, if they are group 1, they are monopositive. If they are group 2, they are bipositive. If they are group 3, which means they have positive 3, positive 4. What about group 7? Group 7, in order to fix the what we call octet rule, they accept 1 because they have a 7 electron in their outer shells. 7 electron. Group 7, they have 7 electron in their outer shells. So to become full outer shell, they should accept 1 electron to become full instead of what? Losing 7. What about group 6? They have 6 electrons in their outer shells. So their charge is what? They accepted 2 electrons, so they are -2. Group 7, -1. What about group 5? They are -3. What about group 3? Positive 3. So they form each and every group should form what we call same kinds of ions, whether they are positive 1, positive 2, -1, -2. Here we have what? Some examples. So electronic structure of the first 3 elements of group 1. Here we have what? Group 2, say group 7. If you consider here the electronic structure, group 1, this is lithium, sodium, potassium. So they have what? They have here you see they have 1 electron in their outer shells. They are in the same group. Here you have 2 electrons in their outer shells. They are in the same group. They belong to group 2. What about 7? 7 indicates you group 7. So this indicates you what? Group 7. Okay, so if you consider this table, this table indicates you the outer shell of electron indicates you the group number. For example, the first 3 rows will indicate you group 1 because they have 1 electron in their outer shells. Say 2 electrons in their outer shells, 7 electrons in their outer shells. What about here? So we want to start group 1. Group 1 is also called alkali metals. So alkali metals is a common name, but they are group 1. When I say group 1 means first column of the periodic table. So you can start from left to right. So going from left to right is called across a period. So first column, before we across the groups, the element is first column is called group 1 or alkali metals. So first column of the periodic table is called group 1, not including hydrogen. So hydrogen is always outside the main group. It is also always what? Outside the main group. So it is not one of group 1, but it behaves like group 1. Similarly, again, it behaves like group 7. So hydrogen is an exception. So hydrogen is always outside the main group. You see this group, they have a properties. We said what? All elements in the same group, they behave in a similar way. Say both physical and chemical properties. So they have a properties. So these are the properties of group 1. Number 1, very reactive metals. Number 1, they are metals. Again, I can say they are very reactive metals. They are soft enough you can cut with a knife. The metal itself, which belongs to group 1, you can cut with a knife. You can cut using your hands. So they are soft enough. They have 1 electron in their outer shells because they are group 1. Low melting point and boiling point. Generally, they have low melting point and boiling point. You see, their melting point is not the same, but it is similar. So generally, they have a low melting point and boiling point comparing to the other metals like group 2, transition metals, and group 3. Their reactivity increases as you go down the group. For example, the group starts lithium, sodium, potassium, rubidium, cesium, francium. So the reactivity increases as you go down the group. So francium is the most reactive one. Okay. Here we have reaction number 1. If you consider here, all group 1 elements react vigorously with water to form hydrogen and metal hydroxide. So they react directly. So this kind of reaction is very fast because of what? It is a vigorous. So they react with water. If you put in, for example, you have a sodium metal or potassium metal or any other metal from group 1, if you put in water, they react directly and it produces what? Metal hydroxide and hydrogen gas. So this is the equation. So sodium is group 1. When you add water, which is a liquid, it produces sodium hydroxide and hydrogen gas. You see, we can't put in sodium metal water. We can't put in. You see, this kind of reaction, it can cause explosion. Because sodium is very reactive. What about potassium? It is more reactive than sodium. What about lithium? Lithium itself is a group 1, but it is lower than sodium and potassium. So this is the general equation of what group 1 element is. What about if I want to write potassium? You can write here potassium, say K, potassium, which is solid state. Potassium, if you want to add water, here you have water, which is liquid state. Then it produces what? It's the same principle. You can only change the metal itself. So it's supposed to be what? Potassium hydroxide. So aqua solution. Aqua means water. So it's a base or say alkaline or any other compound containing water, dissolved in water, plus hydrogen gas. So hydrogen gas, it bubbles off. So this is the equation of what group 1 elements when they react with water, they produce metal hydroxide and hydrogen gas. If you want to write lithium, same principle with this equation. Okay. So they react vigorously with halogens. Same principle. Again, they react with halogens to form metal halide. Metal halide. So this is group 1. Here you have chlorine. Then sodium chloride is forming. So this is called metal halide or halide compound. Halide compound. So can I write? Can we write another metal which is not sodium? Yes, I can write lithium. So lithium, which is solid state, it can react with, say, bromine. It can react with bromine, which is liquid at room temperature. Then it produces what? Lithium bromide, which is solid state. Lithium bromide, which is solid state. For you to balance, you can put here 2 and you can put here 2. So it's balancing. So same principle, they behave in a similar way. They react with water in a similar way. They react with halogens in a similar way. So this is called what? When metals, particularly group 1 metals, react with halogens, they produce what we call halides or metal halides. Metal halides. Okay. They burn in oxygen or air. They burn in oxygen or air, which means they produce metal oxide. Consider this one: lithium plus oxygen, lithium oxide. What about sodium? Sodium plus oxygen, sodium oxide. What about potassium? Potassium plus oxygen, potassium oxide. So they react in a similar way. So these are the reactions of what? Group 1 or alkali metals. What about alkaline earth metals? This is group 2, alkaline earth metals. So this is the second column. As we already mentioned it, the previous group was group what? Group 1, first column. So this is the second group of the periodic table. The common name is called alkaline earth metals. So they have a properties similar to group 1. So these are the properties. Consider these properties. They are reactive metals. Okay. Consider here. This is a typing error. This is a typing error. This is a typing error. So they are reactive metals, but they are lower than group 1. So they are reactive metals. Generally, they are very reactive metals, but they are lower than group 1. They are harder than those in group 1. They are harder, which means they have a higher melting point and boiling point compared to group 1. They are silvery gray in color. They look like this color. They have 2 electrons in their outer shells. If you remember group 1, they have 1 electron in their outer shells. Their reactivity increases as you go down the group, similar way. Their reactivity increases as you go down the group. So the last one is most reactive. Okay, here. They burn in oxygen to form solid white oxide. Same principle with group 1. So this is magnesium plus oxygen, magnesium oxide. So they produce metal oxide. Calcium, if you put here calcium plus oxygen, calcium oxide. What about beryllium plus oxygen, beryllium oxide? So they behave in a similar way. They react to oxygen to produce what? Metal oxides. So they react with water, but they do so much less vigorous compared to the group 1 elements. So calcium plus water, calcium hydroxide plus hydrogen gas. So the product is the same. They produce metal hydroxide and hydrogen gas, but this kind of reaction is less vigorous. Okay. So my students, this is our third class e-learning program. So I want to summarize here. So thank you very much.